Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate sometimes we encounter trig equations where the output isn't some nice value we can use the unit circle to find. So we have to use what's called an inverse trig function in order to find it. So I want to show you briefly what are inverse trig functions, and then we're going to use those in a situation so you can see how it works. So sine, cosine, and tangent each have their own respective inverse function. So let's start with sine. So the inverse of sine is sine to that little -1 notation. So you've seen these on your calculators. It can also be called arc sine of x. So there's two ways to refer to the inverse of the sine function. It has a domain of -pi/2 to pi/2. So it's very restrictive. So what that means is the only inputs for the arc sine must exist in quadrants 1 and 4 of the unit circle only. So be very careful of how you're putting those angles. And if you want any angle in quadrant 4, remember you can't use the positive version of it. You have to use a negative angle, a reference angle, to get to that same location. Okay, so this is a nice picture to illustrate what it is. So nothing from quadrants 2 and 3 can be used as an input into arc sine. Now let's look at the inverse of cosine. So again, it's cosine. You can have the little -1 notation, or it can be called arc cosine. Its domain is from 0 to pi. So that's quadrants 1 and 2. Nothing from quadrants 3 or 4 can be used in the inverse of the cosine function. It's a domain restriction. So it's no longer a function. So notice in inverse sine and cosine, you can actually use the ends of your intervals. They are included. Now, look at inverse of tangent. So again, you can rewrite it as a -1. Again, you'll see that on your calculator, or it's called arc tan. Now look at its domain. It's very similar to arc sine. You see that? However, you cannot use those bounds. Why? Because remember, tangent has vertical asymptotes. It has undefined values at pi/2 and -pi/2. So you cannot use them. So the domain of arc tangent is just like arc sine. It lives in quadrants 1 and 4. However, you cannot use those actual angles there. And also, you cannot use anything from quadrants 2 or 3. So these are your three basic trig inverse functions. So here's a scenario to apply what we just talked about. Solve this equation, sine of x equals 3/4, gives your answer in degrees and radians and round to the hundredths place. So we're going to practice doing both modes just so you can see it. So we have the sine of x equals 3/4. Now, if you look at your unit circle, you're going to notice there's no value on the unit circle that's 3/4, right? There's 1/2, there's √3/2, there's radical 2/2, 0, 1, nothing is 3/4. So we're going to use our inverse. Now, because it's the sine function, we're going to apply the inverse of sine, but we have to do it to both sides. So now what happens here is what happens when you have a function and its inverse get composed together. Remember, we've studied this before. We end up with our identity function, x, and that's what we wanted. Now let's check. Remember, what's the domain of arc sine? It's -pi/2 to +pi/2. So if you don't know this, there's pi/2. So really what this says is 15707, -15707. So that's the domain in an approximate decimal value. Now 3/4, well, that's 0.75. So that's a number that's safely in that domain. So we don't have a domain error. So what we're going to do now is calculate this. So you're going to go to your calculator. Now we're going to do it two ways. We're going to do degrees and we're going to do radians. Now in your calculator, so you can see on my calculator here, it's in degree mode. See how it says DEG? So I'm going to go arc sine. So now see how it's yellow? So I have to do the second button. Activate that. Arc sine. I'm going to type in 3/4. So there's my answer. Now, what is it in radians? So you have to change your mode. So you press your degree button. We're going to go to radians. Press enter. See, now it says rad for radians. So we're going to do the same exact thing.